the balancing of redox equations in acidic mediums and basic medium, right? So but before we start, I want people to join up, so let us wait for people to join up before we start balancing redox equations, right? So in the last class I gave you guys an assignment, which is this, and in the assignment I said you should identify the oxidizing agent and the reducing agent, right? So I would love us to do that first before we advance to the balancing of redox equations. So let me know if you guys are here. If you are here, type I am here. If you are here, type I am here and tap on your screen so you can like the live. Okay. Are you people saying that I have just 2 people here? Okay, 3 people now. People saying I only have 3 people here. Okay, I have Henry here too. Okay, so let's just quickly start with what I taught the last time. The last time I gave you guys an example that you people should identify the oxidizing and the reducing agents. Some people already identified it and they dropped their answers in the comments of the live stream. Everybody tap on your screen. That's the way to like this live. So now let us quickly identify the oxidizing agent and the reducing agent. Let us do it in terms of oxygen transfer, right? Here we have Fe2O3 at the reactant side, and here we have Fe. That means it has lost oxygen, right? It has lost oxygen, right? Here Fe2O3 has 3 oxygen atoms. Here it has lost it. Now it has just become just Fe atom, that's ion atom. It has lost 3 atoms of oxygen to CO, and it made CO become CO2. It made CO became CO2, right? So that's that for that. So Fe2O3 lost oxygen, right? So I believe you all know that oxidation in terms of oxygen transfer is the gain of oxygen, right? The gain of oxygen. So are you people following me? Oxidation in terms of oxygen transfer is the what? Gain of oxygen, right? Gain of oxygen. So the one that loses the oxygen that was gained is what we call the what? I'm asking people a question. I said in terms of oxygen transfer, the oxygen, or let's even use reduction. We all know that reduction is what? The loss of oxygen, right? Loss of oxygen, right? So the one that gains the oxygen that was lost is called the what? The reducing agent, right? So in this case, which of these 2 entities gained the oxygen that was lost? Right? So I'm asking people a question. Some of you guys were not here when we did this class, but I gave them this assignment the last time. So I'm waiting for them to give me the answer before we go on to the balancing of redox equations. You understand? So now, I said oxidation is the gain of oxygen, right? Oxidation is the gain of oxygen, right? So the one that loses the oxygen that was gained, the one that loses the oxygen that was gained is what we call the oxidizing agent, right? So in this equation, what is the oxidizing agent? Which one lost the oxygen that was gained by the other one? You can see this was the one that gained oxygen. CO turned to CO2, right? So who lost the oxygen that was gained? Fe2O3 lost the oxygen that was gained. So Fe2O3 is our oxidizing agent. Right? Do you people support that? Do you people support that Fe2O3 is our oxidizing agent? Do you people support that? Do you people support that? Okay. Charlie Favor, you say you don't understand. Okay. Charlie Favor, if you don't understand, this is what you are going to do. Just go to my previous video. I made a video earlier. I came live and I posted it where I taught oxidation and reduction, how to identify reducing and oxidizing agents. If you watch that video, I don't think you'll be lost again. Right? So what is reduction? Reduction is the what? The loss of oxygen. Reduction is the loss of oxygen. So the one that gains the oxygen that was lost is what we call the reducing agent. So here, our CO was the one that gained the oxygen. CO gained the oxygen that was lost and became CO2. So CO is the reducing agent, right? Because CO reduced Fe2O3 to Fe. Do you understand me now? If you are here, type I am here. Type I am here. So this is the answer to the last assignment I gave you guys. So now I want us to move to the balancing of redox equations. If you get this, let me know. If you are here, type I am here. So now let us go to the balancing of redox equations. If you are to balance redox equations, they can either give you acidic medium, basic medium, or neutral medium. I believe you know what an acid is. Do you people know what an acid is? Or do you people know what a base is? Do you people know what an acid is? Do you know what an acid is? Or let me ask you people, what is an acid? Also, what is a base? Type it in the comments. What is an acid? What is a base? Type the meaning in the comments. Let me hear from you guys. We have over 20 people here, and the live is still on 13 likes. If you know you have joined this live, tap on your screen so that we can be getting more likes. What is an acid and what is a base? I'm waiting for your responses. I'm waiting for your responses before we continue. What is an acid and what is a base? Acids are substances which produces hydrogen ion as the only positive ion. Okay. An acid is a substance that produces hydrogen ions in water. Okay. Let me give you what an acid is. Acids are substances that produce hydrogen ion or hydronium ion, H3O plus, when dissolved in water. They produce either hydrogen ion or hydronium ion. This is hydronium ion. We call it hydronium ion or hydrozonium ion, right? So acids either produce hydrogen ion or hydronium ion when dissolved in water. White bases usually produce OH minus, right? OH minus, that's hydroxyl ion. That's hydroxyl ion, right? That's hydroxyl ion. So let us move to the balancing of our own redox, right? So now we have to balance this redox equation. See, first, let me ask you guys a question, a very simple one. This is a redox equation, and in your JAMB exam, they will tell you if it is an acidic medium or a basic medium. They will tell you, right? So now, in balancing an acidic, this is an acidic medium question. If you want to balance a redox that is an acidic medium, right, you should know that you have to add hydrogen ion, right? Hydrogen ion. Why? Because that's what acids produce when they dissolve in water, right? Because that's what acids produce when they dissolve in water. That's for acidic medium. So what do you think will be added for basic medium? If we add hydrogen ion to the acidic medium while balancing, what do you think we should add to the basic medium? Let me know your answers in the comments. Let me know your answers in the comments. If we add hydrogen ion to acidic medium, what do you think we should add to the basic medium? You'll be given in the question, they will tell you that this is an acidic medium. They will tell you that balance this redox reaction in an acidic medium. They say balance this redox reaction in an acidic medium, right? Why balance itself? Even you yourself, you know that this is an acidic medium. This is what you need to put. You understand? So for basic medium, we add hydroxyl ion, which is OH minus, right? OH minus. So now, this is a redox reaction. And one thing I told you people about redox reaction, I said that in a redox reaction, red, which means reduction, and ox, which means oxidation. Both reduction and oxidation are ongoing. They are ongoing concurrently, or they are ongoing together in the equation. One entity will be experiencing oxidation while the other entity will be experiencing reduction. So I want to ask you a question which I have answered, or which I have explained in my previous class on oxidation and reduction, right? Okay, someone said I should come again. Okay, I said that in a redox reaction, reduction, which is as in the name, reduction and oxidation, both of the reactions occur concurrently, or both of the reactions occur together in a redox reaction. That is why it is called a redox, because reduction and oxidation are happening together in the reaction. That is why it is called a redox. So now in a redox reaction, that means that one entity will be undergoing oxidation and the other entity will be undergoing reduction. So I want to ask you guys a question. In a redox, I've answered this question before, I've explained it. If you attended my previous class, you should be able to know the answer to this question. In a redox, what entity undergoes reduction? In a redox, what entity undergoes reduction? These are simple questions you can see in your JAMB exam. You can just see in a redox reaction, which entity undergoes reduction. As simple as ABC. If you don't know it, you don't know it. If you know it, extra mark. In a redox reaction, which entity undergoes reduction? Correct, Terrace is there. The oxidizing agent. The oxidizing agent undergoes reduction in a redox, while the reducing agent undergoes oxidation in a redox reaction. I have explained this whole. If you don't understand that statement, that if you want me to, okay, let me ask you. I want to know if you guys understand. If you don't understand why an oxidizing agent undergoes reduction in the redox and why a reducing agent undergoes oxidation in the redox, type it. Just type I don't understand, so I will know if I should go back. Because do you really people think that I should go back? Because I've already taught this and I've explained it very simple in a way you understand. When I taught oxidation and reduction, and I taught oxidation and reduction, the video is here on my YouTube channel. You can always watch it. Okay, don't go back. A lot of people are saying I should not go back, so I think we should continue. If you're having issues with it, I've already explained in my previous video. You people should watch the video, right? So in short, an oxidizing agent undergoes reduction while a reducing agent undergoes oxidation. So that is that for that. If you're just joining, you are welcome. Let's keep tapping on our screen to support the live stream. So now, to balance a redox reaction, To balance, are you people following me? To balance a redox reaction, the first step, I'm going to be writing the steps out. For the first one, I'm going to be balancing, but for the next one, I'm not going to be writing the steps out again. The first one is to divide into half reactions. You divide them into half reactions, into oxidation and reduction. You divide them into half reactions, right? So you see here we have MnO4 minus. You write your MnO4 minus. You write your MnO4 minus, right? Write your MnO4 minus. And it gave us what? MnO4 minus turned to what? Mn2 plus. MnO4 minus at the reactant side turns to Mn2 plus. We are dividing them into two half reactions. So our second half reaction is Fe2 plus. Fe2 plus to give us what? Fe2 plus to give us what? This. To give us Fe3 plus. Do you know that in this reaction, you can easily know the oxidizing agent and reducing agent after dividing it into half reactions? See here, Fe2 plus is going from +2 to +3. From one of the explanations that I gave you, that oxidation is increasing. Oxidation is increasing what? Oxidation number. So that automatically tells us that ion is experiencing oxidation. Simply. So the one that is experiencing oxidation is what? The reducing agent. Simple as ABC. Understand? Here, this one is the one that is experiencing reduction. I'm still going to explain, sha. So, after dividing into half reactions, the next step is to balance each half reaction by mass. The next step is to balance each half reaction by mass, right? You balance each half reaction by mass. When I say you balance by mass, that means I'm saying that you should balance it normally, the way you used to balance your normal chemical equation now. You balance each half reaction by mass, ignoring oxygen atom, either oxygen atom or hydrogen atom, if that be the case. You just consider the main atoms that are at the product side and the reactant side. Manganese is at the product side, also at the reactant side, you see. Iron is at the product side, also at the reactant side. Here, you can see that it's already balanced. They are already balanced by mass. There's nothing to balance. We only have one manganese atom at the reactant side, one at the product side too. One ion at the reactant side, one ion at the product side. So they are already balanced by mass. They are already balanced by mass, so there's no need to balance anything again. But if you have another situation where the reactant side is not balanced by mass to the product side, you need to balance it before you continue the balancing of your redox. You need to balance it before you continue the balancing of your redox. Do you get me? If you've been following me, type I am following. If you are following, type I am following, so I can continue. I don't want you to get lost in any way at all. I want you to follow me till the end, because JAMB don't usually ask redox like that, but at least you can see like one redox question or two redox questions. But you see more questions on all these oxidizing and reducing agents. Those ones are very simple. They used to ask a lot. Okay, so I can see that you guys are following. So after you've balanced them by mass, these ones they are already balanced by mass. So one manganese atom, one manganese atom, one iron atom, one iron atom. Those ones are already balanced, so there's no need to balance again. So let me just write them out again. So after that, you are going to get the oxidation numbers. This is the next step. You are going to get the oxidation numbers of the main elements in each half reactions, right? See now, in this MnO4 minus, we have to get the oxidation number of Mn, which is manganese. And I think I have taught you guys this. I have taught you guys how to get the oxidation number of an element in a compound. So we need to get the oxidation number of manganese in MnO4 minus. So let us quickly do that. MnO4 minus, right? We want to get the oxidation number of Mn. Let's say Mn is X. Let's say Mn is X, right? X plus, I believe you all know that the oxidation number of oxygen is -2. -2, I explained in the video on oxidation and reduction. -2. You multiply by the atomicity, which is 4, right? Everything is going to be equal to what? The charge. What is the charge? What is the charge? What is the value of the charge? If you are having issues with this thing, just calm down and go and watch my video on. I came live, I think 2 days ago, to teach oxidation and reduction. Right? I came to teach oxidation and reduction. So I explained everything there. So all of these things I'm doing now, they are already in the video on oxidation and reduction. So it's equal to 1 because the charge is -1. -1. So X -2 times 4 is -8 equals -1. So you take 8 to the other side, to turn to addition sign. So you have -1 plus 8. So our X is equal to +8. +7, right? +7. So the oxidation state of manganese in MnO4 minus is +7. That is what we need. That is what we need. So you just write your +7 here. Right? Write your +7. Write your +7. With this person, I said this video is not fully detailed. That's what I'm saying. Go and watch the video on oxidation and reduction first before you come to this one. Go and watch the video on oxidation and reduction. It is on my YouTube channel. Click my YouTube channel. You will see live. Click on live. You will see the video. You will see the video. If you are feeling lost, that's because you don't know how to calculate oxidation number of elements in a compound. I've already made a video on oxidation and reduction before, and I've already explained oxidizing and reducing agents. I've already explained what a redox is. So if you watch that video before you come to this one, you will not have any issues. No, Elizabeth. No problems. I understand you. I understand that you are trying to get us. But the thing is that you will not be able to get us easily if you have not watched the first video. The first video is like 1 hour 50 something minutes or so. You cannot just expect what we've learned for 1 hour 50 something minutes. Just catch up with us like that. You understand? Go and watch that video, right? Thank you so much. So the oxidation number of manganese is MnO4 minus is +7, right? That's what we just calculated. And the oxidation number of manganese in Mn2 plus is what? According to the law I taught you guys on oxidation law. They are asking, how did you get -2? Wow. How did I get -2? Hey Lord. I've already the oxidation number of oxygen is -2 now. Because it needs 2 more electrons to become stable, it will either share or it collects completely from another atom. I've already explained this in the last video. You should go and watch this thing now. You should go and watch this video. I know what I'm saying now. Okay. See, the fact is that JAMB will ask more questions from the first video that I did. That one that is on oxidation and reduction. JAMB will ask more questions from there because those ones are simple. This one now, JAMB knows that redox is long. They can just give you 1 question or 2 questions on that redox, but they can give you 3, 4, 5 questions on determination of oxidation number, determination of oxidizing agent and reducing agent. So the oxidation number of manganese in Mn2 plus is 2 plus is +2, according to the law I taught you guys last time. The law of valence, that the oxidation number is always the amount of charge on an ion, right? So for Fe2 plus it is +2, and for Fe3 plus it is +3, right? So when you get to this stage, you subtract. This is what you are going to do. You are going to do product minus. I have posted the video. It's Kuku on my YouTube channel. I have posted it, and it is here on my YouTube channel. It is here on my YouTube channel. Go to my YouTube channel and go under my life. You know, you will see different videos I've made. You see my videos, you see my shorts, you see my life. Go to life, you will see my life. I also made a live video on, I think, periodic table and periodicity. Those are things you can learn from. You can watch them and learn from them. So now what you do is that you are going to subtract the oxidation number at the product side minus oxidation number at the reactant side. You are going to do it for both half reactions. So here you are going to be having something like 2 minus 7, right? Because yes, 2 minus 7, because this is the product. Is this not the product? 2. Let me write it. 2 plus 2 minus reactant is 7 minus 7, right? Here product is what? 3. The oxidation number at the product side new minus oxidation number at the reactant side is what? 2, right? So you have something like 2 minus 7 is what? Minus 5. 3 minus 2 is what? 1, right? So the next thing you need to do now, the next step you need to take is to multiply. Are you following me? The next step you need to take is to multiply each half reactions by the product of the subtraction of the oxidation numbers. See now, it's just like I want to cross multiply. What I want to do now is more like a cross multiplication. There are actually 2 ways in which you can solve redox, but me, I like using this way. You can even use balancing with electrons. That's also a very good method, but I like using this one because this one is very fast and I love it. After I explain to you guys, if they give you a question on redox and if you understand this method very well, it's going to be very, very fast for you to answer. It's because I'm teaching, that's why I'm taking time. This thing does not take me more than 30 seconds or 25 seconds. I'm already done. So now you are going to multiply your answer here with this half reaction. Why you are going to multiply your answer here with this half reaction? You have to ignore the negative signs. Ignore the negative signs if you have negative signs, right? So for this minus 12 now, you just have to ignore the negative sign and just multiply your thing, right? So 1 will multiply this one and 1 will multiply this one. It will still be the same. You still have your MnO4 minus to give us Mn2 plus, right? While at this other side, 5 will multiply Fe2 plus. You have something like 5 Fe2 plus to give us 5 will also multiply Fe3 plus, 5 Fe3 plus, right? Are you following me? Are you following me? If you are following me, let me know in the comments. Also, please, if you are just joining for the first time, just tap on your screen. Tap on your screen. That's a very good way to support the live stream. Are you following me? Hey, my back is paining me, sha. Oh, so painful. I've missed a lot. I guess I should come online now. Okay. I know what, you can still watch the recording though. I'll post the recording here on my YouTube channel. So now, you guys are following me, right? Now that we have multiplied with the product of the subtraction of the oxidation numbers, what you have to do now is to bring both half reactions together again. Bring both half reactions together again, right? Bring both half reactions together again, right? So we have something like MnO4 minus, or let's say bring the balanced half reactions together again. MnO4 minus plus, we add our 5 Fe2 plus to give us what? This is our product side, Mn2 plus. Then to give us what again? What's at the product side? 5Fe3 plus. Right? So we have brought the half reactions together again. So the next step to do here is to actually get or to calculate the total oxidation number. The total oxidation number at the product side and at the reactant side. You know, this one, the one that we did here, the oxidation number that we did here was just for a particular element. It was for a particular element. It was for just one element. You understand? But now, the one we want to calculate now is general. The whole of the product side, the whole of the reactant side, the whole of the reactant side, the whole of the product side, right? We want to see the differences in the oxidation number and how we can balance them with adding our hydrogen ion, right? Because it is an acidic medium. So now, you should be following me, or you understand everything now. The total oxidation number of MnO4 here is what? -1. That's the total. So this one is in total. Don't forget that this next stage is total oxidation number. So you write your -1. You are going to write plus. What's the total oxidation number of Fe? 2 plus. It's 2 plus, right? But we have to multiply the +2 times this 5, which is the coefficient of Fe, is going to give us 10. Right? So here we have total oxidation number of Ma2 plus, Mn2 plus is 2 plus, right? So +2. And here we have 3 plus, Fe3 plus. You need to multiply it by this 5. 5 times 3 is what? To give you 15. So you have to add it together. Wow, somebody said she's lost. Kweno, yes on me. You say you are lost. Where are you lost? Let us find you. Owolumit Kayode. Of course, you can share it to your friends now. Anybody can join. This is a YouTube live stream. It's open to everybody to join. I'm waiting for the person that said she's lost. Kweno, yes on me. Where are you lost? Kweno, yes on me. Did you join the live stream the last time when I taught oxidation and reduction? If yes, where are you lost? And if no, where are you lost? Where are you lost to? I think the person that said she's lost, she's not even here again. I think she's lost for him now. Ah, God. She's not talking. I think she's lost. She's already lost. So, I said next stage, how we get the 5 we added to everything. Wow. Is it the 5 that we added to this 5Fe2 plus? The 5 that we added to this 5Fe2 plus and 5 that we added to this 5Fe3 plus? If that's the question, that means you joined late, because I explained here. After calculating the oxidation number of the main element, here it is manganese. Just leave your oxygen. Leave your oxygen first. You don't have business with that. You still deal with it later. We calculated the oxidation number of manganese. How we got 5 we added to everything. That's what I'm answering. You calculated the oxidation number of manganese in this compound is +7. Here manganese is +2, right? You can see. Here Fe is +2, right? Here Fe is +3. You write it out. Then you do products minus reactants. Products minus reactants. Products minus reactants. This is the product. 2 minus, this is reactant 7. 2 minus 7 is what? -5. You write it out, -5. Here 3 minus 2. 3 minus 2 is what? 1. So now you see this sign, like I'm cross multiplying. I'm using whatever I got here to multiply this. If you are using the other method, which is the method of this electron transfer, you still understand these things I'm doing here. You still do it in this electron transfer, but you don't really need that to cancel the electrons. You still do it. but you don't need that electron transfer method, the stress. This one is faster. Why you use this -5 to multiply this other side, ignoring the negative sign. So that was how we got the 5Fe. So 5 times Fe2 plus 5Fe2 plus 5 times Fe3 plus 5Fe3 plus. That's how I got it. See, I used 1 to multiply MnO4 minus 1 to multiply Mn2 plus, and that's why it still remains the same. Then I brought the two half reactions together. MnO4 minus plus Fe2 plus. No, these ones are the reactant side. I put the reactant side together to give us the product side Mn2 plus another product side 5Fe3 plus. After that, I'm trying to calculate the total oxidation number at the product side, and total oxidation number at the reactant side, right? So now we are not just dealing with an element, but we are dealing with the whole compound and the whole of the reactant side and the whole of the product side, right? So now this MnO4 minus, the total oxidation number of MnO4 minus is what? -1. Because of this -1. The total oxidation number of Fe2 plus, it's supposed to be 2 plus, but because it's 5 moles, we need to multiply it by 5. So 2 times 5 is 10. That's why I got this. So this one is Mn2 plus 2, and then this is Fe3 plus. It's supposed to be 3 plus, but because it has 5 moles, so it has to be 5 times 3. That's 15. So you add it together, right? So -1 plus 10 is what? -1 plus 10 is what? -1 plus 10 is what? Nine. Right? -1 plus 10 is 9. 2 plus 15 is what? 17. Right? So now, look at the difference. Here, at the product side, we have 9, a charge of +9. We have a charge of +9 at the reactant side, a charge of +9 at the reactant side, and a charge of +17 at the product side. Oh, thank you so much for loving my explanation. I'm so glad. We have a charge, the total charge at the reactant side is +9, and the total charge at the product side is +17. Now, don't forget, what are we doing? We want to what? We want to balance. Don't forget this thing. Balance. When you say something is balanced, that means it must be what? It must be equal. Right? It must be equal. That means 17. Both of them, they must be equal. See now, 9 is not equal to 17. 9 is not equal to 17. We need to make them equal. It is how we make them equal that now matters. It is how we make them equal that will tell us that this is the medium or this is not the medium. It depends on the medium. They make me to fall in love with my weak subject, and now I'm good in it now. Wow. I'm so glad. That's my joy. So now, okay, see, I told you people that in acidic medium we had H plus. H plus is just like plus sign. H plus will always be adding positive sign to the charge. It will increase the charge, right? It will increase the charge. Why OH minus? Minus, minus will always reduce something. It will always reduce the charge. So in acidic medium, we need to increase the charge. Like if something is small, like if we have, for example, now here, the total oxidation number at the reactant side is +9. The total oxidation number at the product side is +17. We need to make them equal by increasing the lower charge so that the lower charge can be in the same position as the higher charge. Are you people following me? Are you people getting the analogy I'm trying to make at all? This is an acidic medium. The total charge at the reactant side is +9, while the total charge at the product side is +17. Remember, this is an acidic medium, and in acidic medium we usually add hydrogen ion. Hydrogen ion is H+. That means H+ usually adds to the charge of something. It will add to the charge. So we need to add to the charge. That means we need to take the smaller charge, which is +9. We need to ensure that it is balanced with this higher charge by adding H+ to this. H+ will add to it. H+ will increase it to 10. H+ will increase it to 11. H+ will increase it to 12, 13, 14, 15, 16 till it gets to 17. Are you getting me? So it is the number of moles of H+ that will determine the number of how well we want to increase it. Are you following me? It is the number of H+ that we put that will determine how high we want to increase it, right? So now, how will we know the number of H+ to add? How will we know? We just know by removing this from this. What's the difference between 17 and 19? 17 minus 9, Jerry. 17 and 9. So what's the difference between 17 and 9? Very simple, 8. So that means that the reactant side needs 8 moles of hydrogen ion. It needs 8 moles of hydrogen ion to become balanced as the reactant side, as the product side rather. It needs 8 moles of hydrogen ion. You know, hydrogen ion is the positive one, the one that used to increase the value, increase the overall charge of the reaction. That's how we used to call it that time, because I've almost forgotten all of these terms that we usually use when we were in secondary school that time. But it's one thing to understand the concepts. I just understood the concepts. Even if I don't do revisions, I always remember how to solve them. You understand? I just understood the concept. When I understood the concepts, even now that I'm in medical school, that I'm busy with other things, I can still remember how to solve it because I understood the concepts. So what we just have to do is to add 8 to this side so that it can be balanced to this side. So now 8 moles of hydrogen ion. So MnO4 minus plus 5Fe2 plus now we now add our 8 moles of hydrogen ion, right? To give what? To give us what? Mn2 plus. Wow, I'm so glad that you are now falling in love with chemistry. Mn2 plus 5Fe3 plus. You are too good, sir. This is one of the topics I find difficult in chemistry. All thanks to you, sir. Wow. Thank God, thank God, thank God. Thank God. I'm so glad. If you want to join my tutorial too, you can send me a message on WhatsApp. We teach chemistry, physics, biology, mathematics, and use of English. And my JAMB tutorial. If you want to join, this is my phone number. You can screenshot it if you are watching this video now, or if you are watching it later. This is my WhatsApp number. Send me a message on WhatsApp to join my JAMB class. So we have not finished though. There's still one thing we need to do. Now that we have added. Oh, you chatted me to that already. Oh, if you want to chat me, don't send hi, don't send hi, hello. Go straight to the point. You understand? That's when I usually reply. I usually get a lot of messages. So don't be sending hi. Go straight to the point. Oh, I should teach more concepts. Sure, I'll teach more concepts too. You know, we just have to take it one after the other, yeah? So now, let us continue with our balancing of the redox reaction, right? So now that we have added H+ to it. Oh, you said that you want to pay for the class. Don't worry. I'm sorry, Jay, I was busy. Send me another message. Send me another message, yeah? Send me another message. So now, you can see, if you check the overall charge of this, at the product side and the reactant side, to be equal. To be equal now, because MnO4 minus is -1, plus 2 times, 5 times 2 is what? 10, plus 10. Then 8 times 1 is what? 8 plus 8. Everything here, if you add it together, you are going to get 17. Everything here, if you add it together, you are going to get 17. 2 plus 15, 17, right? So that's that. The charge is already balanced. Overall charge is already balanced. But there's still something we need to balance. See, normally with our normal knowledge of balancing of chemical equations, you can see that we still have oxygen atom here, but there is no oxygen atom at the product side. That tells us that this thing is still not balanced, right? We have hydrogen ion here, but there's no hydrogen here. That means we need to add. Me we hate this topic for chemistry. Now me they understand. God bless you for thank you, sir. Thank you. I'm so glad that you people are understanding this thing. Chemistry is so simple. So now you can see that we have oxygen that is not here, and we have hydrogen that is not here too. So the last step to balance a redox reaction is to add water. The last step to balance a redox reaction is to add water. Right? Is to add water. So now, let me ask you people a simple question. I want to see how good you people are, or how you people have been following me. If we want to add water to this reaction now, where would we add the water? Are we supposed to add the water at the reactant side or at the product side? I want to see how sensible you guys are. Are we supposed to add it at the reactant side or at the product side? Good. We are going to add it at the product side. Why? Because there are already hydrogen ion and oxygen ion here. We are adding the water so it can balance them here. We are adding the water to the product side so it can balance the reactant side. You know, according to the law of conservation of matter now, matter can never be created or destroyed. So it has to be equal at both sides. Yeah? You know that balance of equation is based on the law of conservation of mass. So now the question is that how many okay. Let me write the question first before I ask you for that question. It's a very simple question. You know, you cannot just add water. You need to know the number of moles of water to add so that it can be balanced. Everybody, let's keep tapping on our screen to like the live. So many people that want to watch the live later can see that the people that enjoy the live, they really gained from the live and they liked the live. That way they will be eager to watch. So now we want to add water, right? Now you can see we've added water, but to be frank, this thing is still not balanced. We need to know the number of moles of water to add. Now, how do we know the number of moles of water to add? How will you know? This is how you will know. You need to know the number of atoms of hydrogen at the reactant side, and also the number of atoms of oxygen at the reactant side also, and then you can use it to know the one that should be at the product side. How many hydrogen atoms do we have at the reactant side? 8 times 1 is what? 8. Here, oxygen, how many oxygen do we have? 4. Because this is 1 mole. 1 times 4, 4. So we have 8 atoms of hydrogen and 4 atoms of oxygen, right? Inside water, you can see water has H2O. Water has how many moles of? It has how many atoms of hydrogen already? 2 atoms of hydrogen. So if you want to turn 2 atoms of hydrogen to 8 atoms of hydrogen, how do we do it? If you want to turn 2 to 8, what will you do to it? Simple. You multiply it by 4. You understand? All of these things are very, very simple things. These are the logical things that you need to use your head for. You understand? So if you add 4 moles, if you add 4 moles, 4 times 2 is what? 8. That is already correct. 4 times, you see, 8, right? And to balance oxygen, so we have 4 oxygen atoms. 4 times 1 is what? 4 also. So you can see that it's already balanced. This is the balanced redox equation. This is the balanced redox equation. This is a balanced redox equation in acidic medium. You can see the masses are balanced, the charges are balanced, everything is balanced. In a redox equation, you must always ensure that your charges are balanced and your atoms or your masses are balanced. Your charges are the most important thing. If your charges are not balanced in the redox reaction, then you should restart again. You should restart because you have done nonsense. Because you know that in redox we deal more with charge. We can even use the electron method, adding of electrons to it. But that one is too stressed. It's too stressful. You see that if I want to solve the second one now, it will be faster. You see that this one now, this is the first one. So I'm taking this with you guys gently. See, if you calculate the total charge here, you get if you calculate the total charge here, you get 17, right? 17. If you calculate the total charge here too, you also get 17. So the charges are balanced. Also, the masses are also balanced, right? If you've not subscribed to my YouTube channel, you can subscribe and turn on the notification button. I've made videos on organic chemistry. Go and watch them. Organic chemistry from scratch. I've made videos on periodicity. I've taught periodicity here on live, and I've uploaded it. Go and watch it. I've taught oxidation and reduction from beginning. That's the part 1 of this video. This is the part 2. Go and watch that one too, so that you don't get lost. I've made videos on periodicity. Go and watch them. I've made videos on the 13 most repeated topics in JAMB Chemistry. Go and watch them. By tomorrow, I will upload a video also on the 13, 15, either 15 or 13. I'm still making my, I need to go through a lot of things to get it, you guys. So I'm also making the most repeated topics in physics tomorrow. So turn on the notification button on my YouTube channel so that you are not going to miss out. So, do you understand the balancing of redox? Do you understand the balancing of redox? I should ask you this, Jota. Kayode, are you not an engineering student? You're an aspiring engineering student now. This Jota is for medical students. By what time? I come live by 10 p.m. I was just resting today. I was a bit occupied today, so I couldn't come live in time. Sir, do you do physics? I don't teach physics here. Only in my tutorial. We teach physics in my tutorial if you want to join. Valency arc. I've already taught valency now. Hey, Obasu John, did you join my life yesterday? I taught valency, how to get valency sharp. The oxidation number of elements. Kia. The name Maxchem, they show you teaching and what it. You're teaching and what it. I like you. You are too good, sir. I understand everything. Oh, thank you, sir. God bless you. Oh, thank you. God bless you too. If you want to join my class, send me a message on WhatsApp. Send me a message on WhatsApp. This is my phone number. Just screenshot it. Screenshot it now and send me a message on WhatsApp. If you want to join my JAMB class, we teach chemistry, physics, biology, and use of English. Screenshot and send me a message. So let's quickly solve another balancing of redox. I actually prepared 2 for acidic medium, and I'm going to give you guys an assignment. I also prepared 1 for basic medium. And I'm going to give you guys assignments, right? What's my name? Let me ask you, do you people know my name? What's my name? Some people say Maxwell, Maxchem 5. Tinubu, Maxwell. My name is not Maxwell. My name is not Maxwell. My name is Max. Just Max. And that's actually an abbreviation, because my real name is Missy Mao. my real name is Missy Mao. This is my real name, Missy Mao. Max is more like an abbreviation. Missy Mao is my first name. My surname is Asokiri. That's my surname. And X is xenon. Do you people know xenon? Xenon is an element, so it's a noble gas. Xenon is a noble gas. I have special interest in xenon because xenon has some special characteristics. Xenon. You people are taking chemistry, don't know xenon. Xenon, a noble gas, don't know xenon. Don't know xenon. Wow. My name is Missy Mao. MISIMAU. Yeah. Let's solve our stuff. So now, I swear, I only carry chemistry for head and name. It is rare. Okay, so let's solve this redox. This is an acidic medium redox. And I believe you people were following me when I solved the first one. So let us solve this one together. What is the first step? You are the ones that are going to tell me these steps from beginning to the end. What is the first step? What is the first step? Merci, Asha. You're welcome. You can still join us. So we are solving redox. So we want to start a new one now. Are you Yoruba? I understand Yoruba and I speak Yoruba quite well, but I'm not Yoruba. Divide into half reactions. That was the first step. So Cr2O7 2 minus, right, to give Cr3 plus, and then I minus to give I2. Right? Those are the half reactions. What is the next stage? After dividing our equation into half reactions, what is the next stage? I want to see if people really understood. What is the next stage? I want everybody here to be following. Everybody should be typing. Everybody should be typing something. Because when I was asking people, do you understand? People say yes. Some said number the charge. Someone said find the oxidation number. Somebody said balance by mass. Who is that person that said balance by their mass? Aliat, correct. I love you, Aliat. I love you because you followed what I taught you. And that person said balance each half reaction by ignoring. It's not by ignoring mass. So I know so you should ignore mass. So balance by mass. Why ignoring oxygen atom? Ignore oxygen atom. Why you balance by mass? Right? It's only Alias that follow what I explained. We will still everything people are saying, those things are correct. We'll still find oxidation number, we'll still do the charges, we'll still do everything. But that's not the first, that's not the step right now. We need to take step by step. You understand? So we need to balance by mass while ignoring the oxygen and hydrogen atoms if you have hydrogen. So now here you can see this is chromium. We have 2 chromium atoms here. At the right hand side we have 2 chromium atoms. At the product side we have only 1. So we need to make the product side also to be also 2. How do we make it 2? We add 2 moles, right? So we have something like Cr2O7 2 minus to give us 2 moles of Cr3 plus. Do we get that? Do we copy? Then let's move to the next one. This one, we have 1 iodine atom. Here we have 2 iodine atom. How can we balance this? Let me hear from you guys first. How can we balance this? For those that don't know how to balance chemical reaction, for those that don't know how to balance chemical reaction, better go and learn it. I've made a video on my YouTube channel on how to balance chemical reaction. Check my YouTube channel, you see the videos on balancing of chemical reaction, chemical equations. I also want to upload another one because I think some people are having issues because I solved on paper. I'm going to be solving on the board to explain balancing of chemical equations, and I'm going to be giving like 5 exercises after the class. So you will master it then. So if you want to balance this iodine You need to add 2 moles of iodine here at the right hand side, so it can balance with the product side. Right? Are you guys following me? Wow, we have already used 1 hour. Wow. How has the 1 hour been to you guys? How has it been to you? Has this 1 hour been impactful, or has it been wasteful? Have you how has the 1 hour been? We've used 1 hour on this live stream. How has the 1 hour been to you? It has been interesting. Okay, I love that. It's only 30 strands. Hey, I'm on my back. I'm coming. You push away to let me stretch my back. I'm coming on. I want to stretch my back. I'm having back pains. This is not easy. To become a teacher is not easy. Yeah. Much more of classroom teachers. Ouch. What's happening now? What is this orientation for now? Oh, because what was wrong with YouTube now? It's changed because I just put it in like this. They are telling me that the orientation something. No, let's just continue. They can see. So now, after that, after you have balanced by mass, what is the next step you need to take? After you have balanced by mass, what is the next steps you need to take? According to the last one I taught you guys, if you're just joining for the first time, tap on your screen and like the live. That's the best way to support this live. After that, what's the next thing? Why is YouTube doing like this? You see, orientation is locked. Why are they locking the orientation safe? Who sent them work? So you need to get the oxidation number of the main element here. The main element is chromium. Here is iodine. So we need to get the oxidation number of chromium in Cr2O7 2 minus. So Cr2O7 2 minus. Cr2O7 2 minus. I just want to do it somewhere. Cr2O7 2 minus, right? So let's be quick with this. Let's represent our chromium with X. So we have 2x. That's 2 times x, 2x plus, or let's say minus. I'm going very fast now. Minus 2 times 7 is what? Minus 14 equals minus 2. So 2x is going to be equal to 14 goes to this side, it becomes plus. So you have 12. So x is equal to plus 6. People are not kids again. People are science students. I don't have to be treating people like art students. So plus 6. So oxidation number of chromium is plus 6, right? Here it is what? Actually, here we can only take we can take just this, but I don't want to take it like that. I want us to make it in a way that is going to be very. I want to okay. I want to make it in a way you people understand. See, we have 2 chromium atoms here, right? We have 2 chromium atoms here, but the oxidation number of only 1 chromium atom is 6, right? Is 6. So because we have 2, we can actually turn it to 6 times 2. You understand? We can turn it to 6 times 2, which will give us 12. Don't worry, you can do it either ways. You can decide to use 6, you still get your answer. You can decide to use 6, you still get your answer. But me, I want to use 12. When I use 12, let me say at the ending, I will still have to divide through and come to the base, sha. But I like doing my things, satisfying all the rules. You understand? Because we have 2 chromium atoms here, and the oxidation number of just 1 chromium atom is plus 6. So for 2 is going to be plus 6 times 2, which is plus 12. Right? Are you guys following me? So for chromium here, we have plus 3. I'm going to multiply it with this 2, which is number of moles. It's going to be plus 6. Right? Here, This is going to give me, this is -1, right? 2 times -1 is what? -2, right? Here is what? Here is 0. I believe you all know that the oxidation number of an uncombined element is 0. This is iodine. This is the atomic iodine, right? This iodine solid, and it is 0 because it is not combined and it has no charge. It's 0. So now the next step is to what? To do your product minus reactants, right? These are products. 6 minus 12 is what? -6, right? So our product minus reactants. Our product minus reactants. 0 minus 2. 0 minus -2 is what? +2. 0 minus -2. 0 minus -2 is +2, right? So after that, we do our cross multiplication, right? You see that I'm a bit faster now because I've taught you guys that before. So 2 we multiply this, while 6 multiply this. So you'll be having something like 2 times all these ones. You'll be having something like 2 Cr2 O7 2 minus to give 4. We'll still divide through though, but I just like using this method because it will not confuse the students. I'm using this 2 to multiply this, right? And then 6 to multiply this. You ignore the negative sign, right? So you have 12i minus to give us 6i2, right? 6i2. Are you guys following me? So after that, what's the next step? What's the next step? According to what I taught you guys, after this, what's the next step? After this, what's the next step? I don't know what's wrong with YouTube. They just want to stress me. After this, what's the next step? I'm waiting for you guys. After this, the next step is to combine the half reactions again. Combine the half reactions. Terry Strands, are you not here? Terry Strand, are you not here again? I thought Terry Strand was following me before. You combine the half reactions again now. Combine the half reactions first before you calculate the total oxidation number. So 2 Cr2 O7 2 minus, then plus this, our 12i minus to give 4 Cr3 plus to give what again? To give plus 6i2. You can see this is 2, 12, 4, and 6. All of these are even numbers. 2 can divide through. You can decide to divide through by 2. You understand? That's what I actually see. You can see the essence of that. The essence of that I did there. So it will still be the same if you divide through by 2. You understand? So that's one of the reasons I just did it there. But even before let's not even divide through by 2. If you divide through by 2, you still get the same answer. But let's continue like this. If you want to work with big numbers, you can continue like this. But should we just divide through by 2, or we should work with big numbers? Anyone that we work with, we still get our answer. Should we divide through by 2 before we balance the charge, or we should just work with the big numbers? Okay, so we can divide all of these things by 2 because 2 can divide this, 2 can divide this, 2 can divide this, 2 can also divide this. And so if you divide through by 2, you get something like 2 we divide this, it will be 1 now. So we have something like C2 Cr2 O7 2 minus plus our 6 iodide to give us 2 Cr3 plus, then plus 3i2. Do you people get what I'm explaining? Do you people get what I'm explaining? If you are just joining for the first time, my name is Max. I'm a chemistry student. Right? I teach people chemistry. I teach JAMB students who experience chemistry. Right? So if you don't like, keep liking. Well, somebody is just typing no now. After we have already made this decision. Okay. Why are people typing no? Like, is the no that you people are not getting, or what? Are you typing no like to say that you are not getting, you did not get the explanation, or what? Afensumu Augustine and Ogechi Ugu and Owolumate Kayode. Is it that, are you saying no that you don't understand? Okay, you are saying that you don't understand. Okay, you know what? We are going to work with small numbers, we are going to work with big numbers. It's still the same thing. This is a simple law in balancing chemical reaction now. See, if you want to balance a chemical reaction, and all the this thing, all the compounds in the chemical reaction, they all have elements, or they all have number of moles that are divisible. You have to divide it to the lowest term now. This is just like mathematics. This is a simple mathematics too. This is simple mathematics. If you have an equation now, which equation can I use? Oh, okay, let me find one equation. Let me say, if let me find just one acid and base equation. If NaOH reacts with HCl, I want to give you guys an example, and we have something like sodium chloride plus water, right? If you have to balance this, we have 2 hydrogen. You have to like 2. You have to like 2. I'm trying to balance this balance of chemical reaction. I'm trying to balance this. This 2. No. There's no need to put 2 safe, because you already have. You don't need to put 2 here, go safe. You already have 1 chlorine, 2 hydrogen, 2 hydrogen. 1, 2. It's already balanced safe. There's no need. It's already balanced. You can see the way it's balanced, right? See, if this thing, if you now see something like 2 NaOH plus 2 HCl to give 2 NaCl plus 2 H2O. This thing, you cannot write it like this again, because all of these things, all of these moles, they are divisible. If you can divide all of them through, just divide. This is 2 can divide 2, 2 can divide 2. You need to divide to the lowest term. You get what I'm saying? That anything cannot divide again. So that's why you have this again. This and this is still the same thing. This and this thing is still the same thing. So we can still decide to work. You just have to bring it down to the lowest term. It's just like equivalence fraction. 1/2 is also the same thing as 2/4. Also the same thing as how do they call it? What's the next one? I'm gonna say 4/8. These are just equivalent fractions. It's still the same. Do you grab? So that's why. So if we work with this, or we work with this, we are still going to get the same answer. We are still going to get the same answer if we bring it to the base. So let us continue. So now that we have already joined the equations, the half reactions together, and we've even divided, we took it down a bit. So now the next my hand though. Now the next thing is to now calculate with respect to the overall oxidation number at the reactant side and the overall oxidation number at the product side, right? The overall oxidation number at the reactant side, here we have -2 for Cr2O7, 2 minus, we have -2 plus for I, we have 6I, right? 6I minus. So that's -6, right? That's -6. That's -2 minus 6 is what? -8. I believe people get that. I believe people get that. This is -2, right? And this is -6. If you add this together, -6 minus 2 is going to give you -8, right? Here you have 3 plus, so 3 times 2 is going to give you what? +6, right? This one is 0. 0 times 3 is 0. 0. So at the product side, we have what we have? We have +6. At the reactant side, we have minus 8. So minus 8 is not equal to plus 6. Are they equal? They are not equal, right? So what do we have to do? We need to elevate one of them. You know we are balancing in acidic medium. In acidic medium, what do we normally add? In acidic medium, what do we normally add though? In acidic medium, what do we normally add? In acidic medium, what do we normally add? We add water, I know now. There's still one thing that used to elevate hydrogen ion. Hydrogen ion, right? Hydrogen ion. We need to add hydrogen ion. I believe you all know that hydrogen ion is the one that usually elevates the lower entity or the lower side. It elevates the charge of the side that has a lower charge. You understand? So in these two charge, this one is for the reactant side and this one is the product side. Which one has the lower charge? Is it the reactant side or the product side? Which one has the lower charge? Which one has the lower charge? Is it the reactant side or the product side? The reactant side. The reactant side has the lower charge, which is minus 8. So, wow, who is saying product? Is inside plus 6 and minus 8, which one is lower? Inside minus 8 and plus 6, which one is lower? This is a simple question. Inside plus 6 and minus 8, which one is lower? Minus 8 is lower now. That's why I'm telling you guys that it is the hydrogen ion is always there to elevate or to help the lower charge to become equal with the higher charge. Our aim, you remember, we want to balance. Our aim is to ensure that the two charges are the same. And if they want to be the same, in acidic medium, we need to take the smaller one. We need to energize. When I say we need to energize, we need to support the smaller one by increasing the number of charge so that it can balance with the other side. This is minus 8. We need to carry from minus 8 to 6. We need to carry this minus 8 to 6. Right? Do you people understand me? So now, this hydrogen ion, we need to add it to the reactant side so that it can balance with this other side. So how will we know? We just say 6 minus 8. It will tell us. Or is that not I'm coming on? From minus 8, then it will come to 6. That's it now. That's it. That's going to give us 6 plus 8. And that's going to give us 14. Yes. That's going to give us plus 14. How did you get plus 6? How did I get plus 6? 2 times plus 3. 2 times plus 3 is plus 6. Then this iodine is 0. This iodine is 0. So 3 times 0 is 0. So there's nothing to write. 2 times plus 3, that's why I got plus 6. So now we know that minus 8 and plus 6, they are not the same thing. Minus 8 is lower. Minus 8 is lower, so we need to help minus 8 to get to plus 6. So how many or how much, or let me say, how many hydrogen ion will you add? How many hydrogen ion will you add to minus 8 to get to plus 6? That is what I just calculated. All you just have to do is to subtract this from this. And that's what I did. I subtracted this from this, which is 6 minus this. 6 minus 8. Minus times minus is what? Plus. So 6 plus 8 is 14. So we need to add 14 hydrogen ions. That's 14 H plus to support reactant side so that it can be equal to the product side. Are this explanation clear? I don't want a situation where you will come and be saying that Maxchem did not teach us well. Maxchem did not teach us well. Because when I'm teaching people now, when I'm repeating things, So we need to add 14 hydrogen ion to the reactant side, to the less privileged side. We want to help the less privileged. The reactant side is less privileged. We want to help it with hydrogen ion so that it can be balanced with the product side. So what was at our reactant side? Go save Cr2O7 2 minus. This way I'm sleeping here. Cr2O7 2 minus plus 6I minus plus 14 hydrogen ion to give us what? 2Cr3 plus 3I2. I think that's all now. So now you can see we have not finished. There's still one thing that we need to add. What do we usually add at the end? To balance? When we finish all the balancing, what else? We want to add water, right? We want to add water. How do we know the number of moles of water to add? We have 14 hydrogen atom, while we have 7 hydrogen, 7 oxygen, right? So we need to add water. That's the ending part. We need to add water. Yes. How many moles of water do we have to add? Let me write this stuff again. Cr2O7 2 minus plus 6I minus plus 14H plus to give 2Cr3 plus all of these things are things I should be teaching on TikTok too, but TikTok does not allow us, they don't give us the time to do all of this while. Then plus water. Now, how many moles of water do we need to add? We will know from this. We have 17 or 14 hydrogen atoms at the reactant side and 7 oxygen atoms at the reactant side. We need to take them to the product. If we have 14 hydrogen atoms at the reactant side and we already have 2 at the product side, how can we turn 2 to 14? By multiplying it by 7. These are things you should do in your brain. So 7 times 1 and 2 for oxygen is 7. We have 7 oxygen atoms. So this is the balanced reaction. Cr2O7 2 minus plus 6I minus plus 14H plus to give 2Cr3 plus 3I2 plus 7H2O. This is a balanced redox reaction. The charges are balanced. The masses are also balanced. That is a balanced redox reaction. Do you people understand? This is a very, very simple thing. Very, very simple thing. In acidic medium, we help the less privileged. In acidic medium, we help the less privileged by adding what? Hydrogen ion. In acidic medium. Hey, do you people understand? Okay. So I think if you see any question on oxidation number, oxidizing agent, reducing agent, valency, oxidation state in your JAMB exam, I don't expect you to have any problems with them. Even if you see questions on redox, they ask you to balance redox, tell them that redox is simple. Maxchem don't teach me. I don't get issue with them. So let's do one last example before we sleep for tonight. But this one are basic medium. Basic medium, they know they help less privilege. They even carry person go down. for basic medium, they know they help less privilege. In acidic medium now, they used to carry the poor to the rich. They used to help the poor to get to the rich. But inside basic medium, they carry the rich, they carry them come down, come meet the poor. You get that analogy? Now wetin basic medium they do so. Basic medium go carry person wey don't get money, go carry am come down, make e come meet person wey don't get money. They go collect the one wey you get. Yeah, so now wetin basic medium they do so. So in basic medium we usually had OH minus hydroxyl ion. You know that bases give only hydroxyl ion as the only negative ion when dissolved in water. So it's basically the same step. It's basically the same step. Everything is the same step as the acidic medium. The only difference is just that instead of adding your hydrogen ion, you add your OH minus. Basic medium na Lagos. So Lagos they carry rich person come down. It is well. It is well. Should we solve this basic medium, or you want me to give you as assignment? Should we solve this basic medium, or you want me to give you as assignment? I didn't know that we even take this much time, safe. Should we solve this one, or you want me to give you as assignment? Let me know so we can know which one. Okay, we should solve it. How many people are here, safe? How many people are on this live stream right now? If you are here, type I am here. Okay, 3 people said we should solve. 2 people said we should use it to do assignments. 11, okay. Okay. Solve a beg, okay. Let's just solve this. Let's solve it. A lot of people are saying we should solve. Let's just solve. Obedience, you are saying assignments. Is your phone off for me? Solve on time. Data. Okay. Let's solve. Let's just solve. I'll give you guys another assignment. Let's solve this. I'm going to be fast though because I believe you already know the steps. Hey. I'm on my phone save is already. It's already on 20% safe. So let's solve the first thing now. You divide into half reactions now. MnO4 minus to give MnO2, right? Then Fe2 plus to give Fe3 plus, right? After that one, you balance by mass, right? You balance by mass. 1 Mn here, 1 Mn here is already balanced. 1 Fe here, 1 Fe here is already balanced. So you don't have issue with that. It's already balanced. I don't need to balance it again. Don't worry, I'm going to be fast with this one. Next thing is to balance by charge, right? Balance by charge. See here, I might not write this thing. You people are already scholars. You people should be able, by looking at this compound, you people should be able to know the oxidation number of manganese in this compound. Use your head. If you see inside JAMB exam, it's not every time that you write. The total oxidation number is equal to -1, right? You know that oxygen is -2, right? -2 times 4 is what? -8. -8 comes to the other side. That's +8. That's +8 minus 1. That's 7. So, +7. If you don't understand, carry book and solve. That's the operation I want to do for you guys now. That's what I want to be doing. What is the oxidation number of manganese in MnO2? MnO2, ordinary MnO2. You should know that this one is equal to 0, right? -2 times 2. For oxygen, -2 is oxygen is -2, right? -2 times 2 is what? -4. -4 goes to the other side, that's +4. So the oxidation number of manganese is +4. If you don't understand, carry book and solve. I will oppress some of you people that don't know how to solve this thing with ice. It's not compulsory for you to carry book. Use ice to solve it. That's why I've been teaching you people how to solve it with paper, so that you people will use ice inside JAMB exam. If I were to be the one solving all this inside JAMB exam, to not take me to 20 seconds, I'll finish solving one redox. 20 seconds, I'm done. All these things, if I'm doing this, I will not write all these things. So for Fe2 plus is +2, for Fe3 plus is +3, right? So you do your product minus reactant now. 4 minus reactant, 4 minus 7 is what? -3 now. -3, right? Our 3 minus 2 is what? 1 now. You do your cross multiplication now. 1 will multiply this one. So you have, see here, this one. I want to take you people on another level. I don't want to write it out. I want to combine it at once. You know, before I will write MnO4 minus MnO2 clinical. I will not write 3 times this one, 3 times this one. So I will write that. I don't want to do that one again. I want to write it out together at once. I want to combine it together. You people have been following me, so you people should understand. So MnO4 minus, then the 3 that I will use to multiply this one, plus 3Fe, Fe2 plus, to give MnO2 plus 3 Fe3 plus. Do you people understand? I want you people to be following me on a higher level now, because people need speed also. It's not serial. So now you need to calculate the total oxidation number. Understand? Here is what? -1, right? -1. This is 3 times 2, right? That's 6. So -1 plus 6 is what? 5 plus 5. You can just write your plus 5. That's total now. Here, this one is 0. MnO2 is 0 because it doesn't have any charge. This one is 3 times 2. This is 9 now. This is 9 now. This plus 9 now. So now, what you have to do is to balance bar. Is to balance with what? This is a basic medium. You need to balance with what? OH minus. You need to take the rich to the poor. Don't forget that thing. You need to take the rich to the poor. 5 is not equal to 9. Which one is richer? Which one is higher? 9 is higher. So you need to take the rich to the poor. You understand? You know that minus will reduce something. So we need to reduce this 9 to 5. And if we want to reduce it to 5, we need to do 9 minus 5. That will give us 4. So now, 4. You know that 9 minus 4 is 5 now. So we need to reduce this 9 by 4 so that it can turn to 5 by adding OH minus. You understand? So you have something like... So where are we going to... Wait, let me ask you a question. So where are we going to add our OH minus? Is this going to be at the product side or at the reactant side? If we want to write our OH minus, is this going to be at the product side or at the reactant side? Confirm product. It's going to be at the product side, because the product side is the one that have an overall oxidation number of 9, and it's the one that we want to degrade. It's the one that I want to take down to come and meet this plus 5. You get what I'm saying now? MnO4 minus plus 3 Fe2 plus, right? To give us MnO2 plus 3 Fe3 plus, then plus 4 OH minus. You understand why it is 4 OH minus, Abi? Because we need 4. We need to take it down by 4 so that it becomes 5 now. If you remove 4 from 9, it will become 5. So that's what I did. So if you calculate the total charge here now, -1. This is plus 6. This is going to give you 5. And this is 0. This is 9. 9 minus 4. No, 4 times -1 is 4 now. -4. -4 plus 9 is plus 5. So they are equal now. The Gaussians must understand this because that's their hobby. Hey, you are not serious. So in short, we have already balanced this like this. So it's only remaining one thing. One thing for this thing to be balanced. And what is that thing? It's only remaining one thing for this thing to be balanced. Only one thing. That last thing that we usually add. Water. Confirm. It's only remaining water for this thing to be balanced. It's only water that is remaining. So where are we going to add the water? Are we going to add our water at the reactant side or at the product side? Where are we going to be adding our water? Is it at the product side or at the reactant side? Which one? We are going to be adding our water at the reactant side. Yes, we are going to be adding our water at the reactant side, because if you check the reactant side has oxygen, right? But it does not have hydrogen. But the product side has oxygen, also has oxygen, and also has hydrogen, right? This product side has hydrogen, but reactant does not have hydrogen. So we need to add water here to compensate for the hydrogen. So it has to have hydrogen too. It has to have hydrogen. So we have something like MnO4 minus plus 3 Fe2 plus. Let me just write water first. We'll still determine the number of moles of water. H2O to give MnO2 plus 3 Fe3 plus 4 OH minus. At this side, how many amount of water? Okay, let's just use our hydrogen to determine it. Let's use hydrogen. At this side, how many moles of hydrogen? How many atoms of hydrogen do we have? At the product side, how many hydrogen? From this OH, how many hydrogen? 4, Abi. 4 times 1 is 4 now. So 4 hydrogen, right? 4 hydrogen. 4 hydrogen atoms. 4 hydrogen atoms. And here we only have how many hydrogen atoms? 2. 2 that is in water. How do we turn 2 to 4? We multiply it by 2. So 2 times 2 is going to give us 4. So we are going to put 2 here, 2 moles of water. So 2 times 2 is going to give you 4. So we already have 4 atoms of hydrogen, 4 atoms of hydrogen. Let us check if our oxygen is also balanced. We have 4 oxygen here and then 2 here. 2 times 1 is 2 now. So 2 plus 4 is what? 6. So we have 6 oxygen. So let's check if we also have 6 oxygen here. We have 2 oxygen here and we have 4 here. 4 times 1 is 4 now. So 4 plus 2 is what? 6. You can see we have 6 oxygen, 4 hydrogen, and the charges are also balanced. We have 1 Mn, we have 1 Mn, we have 3 Fe, we have 3 Fe. So you can see everything is balanced. This is a basic medium. You see that we used OH minus to balance the basic medium. So that is that for that. Let me give you guys assignment. My assignment are going to be on acidic medium because most times JAMB like asking for acidic medium, but JAMB does not really like asking this thing. It's just once or twice that they used to ask, but at the same time you can see it in WAEC. WAEC can ask you. You people that are doing WAEC or NECO, you can see it too. JAMB also asks. JAMB also asks. JAMB also asks. Understand? So let me think of a redox to give you guys. Okay, let me give you guys like 2 first. Let me give you guys like 2. People should go and balance it. Depending on the time you are watching this video, I want you to write the answer in the comments. After balancing, write your final answer in the comments. I will mark it. SO3 2 minus plus MnO4 minus, that should give us SO4 minus SO4 2 minus, yeah, SO4 2 minus, then plus Mn2 plus. So this is an acidic medium. These are acidic mediums. So these are acidic mediums. The 2 questions I want to give you are acidic mediums. The questions I want to give you are acidic mediums. You really helped my life. I've been on this particular topic since last year. Wow. Is it last year that you want to write or what? What question should I give you again? Okay, let me give you another one. Let me use hydrogen peroxide. H2O2 plus MnO4 minus. That should give us oxygen gas plus Mn2 plus. Yeah. So these are both Are you guys here? If you are here, type I am here. If you are here, type I am here. Okay, so I'll give you guys assignment too. I've given you guys assignment too. I've given you guys assignment too. I've given you guys assignment too. -2 minus 6 plus -8. Okay. Should I give you guys basic medium? Let me just give you guys one basic medium, because I can see that so people are already asking what is the cash. See, even are you people not the one that is supposed to be giving me money, safe? Cash price score, cash price name. Let me give you guys one basic medium. So It's not be only acidic medium. MnO4 minus. That should react with iodine minus to give us MnO2 plus I2. Yeah. Yes, that's MnO4 minus plus I. Okay, that should give us. This is a basic medium. This is in a basic medium. This is in a basic medium. So, after solving, these questions are very simple. Number 1 and 2 are acidic mediums, while number 3 is basic medium. So, you people should solve it and drop the answers in the comment section. Hey, so that's that for today. Or that's that for tonight. I don't think you people should have problems with balancing of redox again. Yes. I don't think you people should have problems with balancing of redox again. Hey, I'm on my back. Let's be here till daybreak. You and who? You not see my eyes. I should be here till daybreak. You want to kill me? You want to kill me? You want to kill Maxchem? If you kill Maxchem, who will the people that want to take JAMB next year, who will they see? You don't black finish. Oh. Shade sin. Shade sin. Shade sin. That's why a lot of people saying that I'm dark. Hey, I'm dark. It's because I'm busy now. It's because I'm busy teaching people now. So I should stop teaching people and I should start doing skincare. Should I start doing skincare? Should I start doing skincare? Don't worry. Maybe I think I should stop teaching and start doing skincare. That way I'll become fair. I'll become fair again. That's what you want now. Those are the things I'm sacrificing. I'm sacrificing my skin, my time for you people. You are here, you are saying you don't black finish. Oh. Imagine. Me that I was a fine boy, hot kid. Because of you people, I'm dark. Jenny's glow. Terry Strand, you can recommend for me. Come and recommend for me, Jerry, so that I will stop teaching. I'll start using skincare. Even me too. I'm not bad now. See me now. I'm still fine. The way I'm dark, I'm still fine. You don't know that black is beauty. The girl I want to marry, I want the girl to be dark. Black is beauty. So that's it. In short, I believe that you people should be able to solve any question you see on Redox now. Redox is simple. Physics is better than chemistry. I just want Maxchem to admit. Don't worry. The thing is that we don't argue facts. I will not argue with you. Because it's a fact. Chemistry is better than physics. We don't need to argue. So we don't stress ourselves to argue what we know that is true. We know that our chemistry is better. So why argue? We don't need to. Black is beauty. Still protect your skin from sun. See, the fact I don't go out. It's not only sun that can make people dark. I don't go out. I'm always inside. So it's not sun. Chemistry is better, yes. Oh, people should not come and start argument that we will not finish. Chemistry and physics, they are both of them, they are good. It depends on what everybody wants, sha. It depends on what anybody wants. Yeah, even stress makes people dark. People are already talking. That has a big light jaw. It is well. Chemistry is sweet too. Interesting. Now questions go tell you it's easier to contend with. I love chemistry. Is a very sweet thing. chemistry. Very sweet. No stress, no wahala, nothing. Just be solving, be getting your answer. Is there class tomorrow on YouTube? I don't think so, because tomorrow I want to upload a video. So by that time, I'll be busy editing the video on YouTube. It's a video that you people have been requesting for. You people have been requesting for the 13 or the 15 most repeated topics in physics JAMB exam. So I have to sit down and make research and check everything, how it has been going over the years, to pick out the topics for you guys and what you need to know about those topics, so that you people can score high in the JAMB exam for physics, biology as well. So we might not host a class tomorrow, but there will be a video that you will learn from surely tomorrow. It can even be solving videos. I can start to be solving, because I've brought my board to my hostel too, to teach you people. You can see the board. You can see the length I'm going for you guys. You people are not saying thank you. I know what to do. Where is this power bank? Is my code there? If you have not liked the live, like it. We are still at 50 likes. Thank you. If you have not liked the live, now is the time to like the live. Like the live, we are still at 50 likes. So that means that if people come, they'll just see ordinary 50 likes. It is well. Thank God. Kayode. Obedience, thank God. Who is the person that I don't like again? Okay, 50 likes. You have tried for us. We appreciate. Okay. Good. That's so great. I'm gonna look at my eyes. It's not easy. I don't know what to use to compensate for this sleep. I need to sleep and I need to read as well. This life go help us. I'm breathing out it. It's not easy. You say mentor, your mentor is passing through a lot, but you people don't know. You people don't know what I'm passing through. Thank God. Many of you people don't know what I'm passing through. Just see somebody, you're calling the person mentor. You don't know what the person is passing through. If you want to be like me, are you sure you'll be able to survive? If you become like me, are you sure you are going to survive? I'm just asking you. I just want to know if you'll be able to survive with handling a lot of things together. Medical school, some people are even doing medical school, they are still not stable. Not to talk of even bringing another thing again to come and join. You can survive to know what's there. Okay, this one is this one is other than Tinubu. This one is other than Tinubu. You want to ask one question? What's the question you want to ask? This one is other than Tinubu. This one is other than Tinubu. You know, like it's like you used to see. You know how it's like you used to see. I got 292 last year, but because of this 7 in chemistry for WAEC, I wasn't given. Which course did you choose? Why this one they laugh anyhow? Nah, Ogbenero obedience. Which course did you choose, Kayode? Oh wait, Kayode, are you not the one that wants to take engineering? You will know that I said engineering or nothing, or that might be corrected you that is engineering or engineering. Okay, make engineering. Yes, you need to get at least a credit in English and in chemistry. At least a credit. They cannot give you. Hope you've done another O level, Sha. Hope you've done another O level that your chemistry is good. It's not just about the UTME alone. No. The O level too has to be. I don't actually know though. I don't really know. I don't actually know though. I don't really know, but at the same time, you just have to ensure that you have a good. But at the same time, you just have to ensure that you have a good JAMB score.